So again, I want to, talk about the domain of functions. If you've been following my videos, you would have seen me talk about the domain of functions before. But something prompted this. Some of my students keep asking questions about them, so I feel, and of course they requested that I should explain again with more examples the concept of the domain of functions. So if you're a new person to the channel, you don't get bored. It's all for the sake of achieving our purpose. Not everybody is smart enough in mathematics, so we need to take time to ensure that everybody is on the same page as much as possible. So that's the reason for this. So I repeat the definition. The domain of a function f defined from a set A into another set B is a subset I denote it by this. DOM of F, subset of which set? Of the set A, from where the function takes its values. So that's precisely what we mean by domain of a function. It's a subset of the set A from where the function derives its values. It's possible that it is the whole of A, no problem. But nothing says, no rule says it must be the whole of the set A. And so where it takes its values from is what we call the domain of your function. The computer scientists will call it the input set, and of course it makes sense. The input set is what we call the domain of your function. So let's take these examples and add the ones we had. Look, let me give f at x, or f, okay, let me just simply write h of t to be the square root of 4 minus t squared. The question is, find the domain. I will add again and the range of h. So I want to add the two together so that we don't, reserve a different time for studying the range. We've already studied the range, yeah. So now we want to emphasize on that, as I remarked earlier, is for those who may have not understood us well and they're requesting more examples. So this is this example. It is also important to note that we said all functions we're dealing with in this course are real valued functions of real numbers, of real variables rather, meaning the domain set may be the whole of R, it may be a subset of R. The range set may be the whole of R, it may be a subset of R. So in this case precisely, we want to know who is the domain of this function h. In that case, there is doubt whether the domain is the whole of R or not. So let's try to compute what the domain is following this rule of definition. So we start this way. Notice that for square root of a number, a real number to give you another real number, that real number must be non-negative. So it means that for this to be valid as a real number, so we must have that 4 minus t squared must be bigger than or equal to 0. For square root of 4 negative this to be a real number. This is the first thing to keep in mind. Alright. Having said this, let's find all real numbers t such that 4 minus t squared is bigger than or equal to 0. And so we need to solve this problem. 4 minus t squared bigger than or equal to 0. This says that 4 alone is bigger than or equal to t raised to the power 2. And that is t squared is less than or equal to 4. This is what we have. Okay. How do we determine all t such that t squared is less than or equal to 4? This is true, means that t squared minus 4 is less than or equal to 0. And this again means that I can write this as difference of 2 squared. So this is t squared minus 2 squared is less than or equal to 0. And which means that t minus 2 multiplied by or plus 2 multiplied by t minus 2, anyone can go first, no problem, is less than or equal to 0. This is what we get.